Let's talk about where this goes next, because I mentioned in the previous video, at this point you pretty much know the rules for differentiation. We'll add a couple of tiny things along the way, but the chain rule is really the big rule. It's kind of the penultimate rule, if you will, for differentiation. We've also talked in the past about a derivative. If you see that d dx notation outside of something, that's an operator. Well, we know that we can use an operator to any side of an equation as long as we do it to both sides. So let's kind of pose a problem to ourselves here. Let's say, what if we wanted to take the derivative and really I should probably say, what if we wanted to take the derivative with respect to x, our independent variable, so that dy dx idea, this derivative of y with respect to x. So if we wanted to take the derivative with respect to x of both sides of the equation, well, let's throw an equation up here. Let's say y cubed plus y squared minus 5y minus x squared equals -4. So if I have this equation and I want to take the derivative with respect to x of both sides, in other words, what I want to do is I want to take the derivative with respect to x of the left side, y cubed plus y squared minus 5y minus x squared, and set it equal to the derivative of the right side, the derivative with respect to x of -4. Hopefully you recognize that I can do this. I can do any operator to one side of the equation as long as I do it to the other side. Hopefully you also recognize that this right side over here is 0. That's not going to be a problem for us in our next topic. The derivative of -4 we know is 0. The question is going to be, what do we do over here? Because I know how to take, for example, the derivative of x squared is 2x, so the minus in front, that would be minus 2x. But over here I've got functions of y. I've got y cubed, I've got y squared, 5y. How do I take the derivative of a function of y with respect to another independent variable, in this case x? And the answer actually comes to us from the chain rule. So the chain rule will allow us to take the derivatives of these functions of y. So y cubed, y squared, with respect to x, through a process that we call implicit differentiation. And really, all it's going to do is it's just going to give us another application of the chain rule. And it's going to be a really huge moment for us. See, I can't really solve this equation for y equals and get some sort of function of x over on the other side. Because I've got different powers of y, there's really nothing algebraically I can do to get this ultimate y equals moment. But I am going to be able to take the derivative of both sides and get a dy dx, or the rate of change of y with respect to x equals kind of moment whenever I take the derivative of both sides of that equation. And that's through a process called implicit differentiation. And implicit differentiation actually is going to be what unlocks a lot of the really neat real-world applications of differentiation that will be the heart of what we do in Unit 4. So in our next lesson, we'll learn how to work with this left side of the equation here, where we want to take the derivative of a function of y, but we're going to do it with respect to x, and we'll cover that in topic 3.2.